Hello everyone, my name is Torayan Inessa, and today I'm going to talk about the first homework of the database systems, which is about basic SQL queries. Let me share my screen and show you. Okay, so let's start. First of all, I want to show you the schema that we're going to work on. Here we have not so many things. We have orders, info about orders, customers, employees, products, and order details, payments. So yeah, for some questions we're going to use solely one table. For some of them, we're going to combine two tables, or it's possible to even do with more. So let's just jump right into it. So the first question asks us to get all the orders with cancelled status. So we need to have a look at our orders table and see that we have here a column which is named status. And actually it contains values in string format, which are like different shipped, on hold, etc. But we need only the ones which are cancelled. So for those reasons, we're selecting everything. Asterisk means all of the columns from orders. Here we're specifying the table, and we can add a condition using this where, and we write where status equals cancelled. Okay, so I think this is pretty straightforward. And actually, since I have multiple queries, you need to use this fourth functionality to execute them in the separate tabs to see the results like this, like I have in here. So as you can see the result, we have all of the columns from the orders table, but in the status, we have only the ones which are equal to cancelled. So the rows where status is cancelled. Okay, the second problem. Get the list of all employees and display only their first and last names. Order them by alphabetical order of their full name. Use the string concatenation to display the full name as first name plus empty string plus last name. All right, so we need to have a look at the employee table. Here, as you can see, we have last name and first name, but we need to combine them to get the full name. For that reason, we're going to use this concat function. And in here, we specify the arguments that we want to combine. In this case, it's first name, last name, and we are putting a white space to have a space between these characters. And with the keyword as, you can rename the column to make it more beautiful. Because if you don't, you're gonna get a column which is named like this, concat, and the arguments inside. So we do this renaming part. Also, it says that we want to order them alphabetically. Since we have the values as strings, but if we use ascending order, it will do the job alphabetically. So we are using the order by, and we have here ascending, descending, but we want ascending. And we are specifying the column, which is, pay attention, the new name, which we created full name, and we are using it. So the results when we execute this query is the following. We are getting full name combined, and as you can notice, it is ordered, just as we wanted. Okay, let's go on with the third one. List each order ID with their total sum of products quantity ordered. Okay, so from this question, it is very logical to notice that we are going to have some order ID and some value, order ID and a value, but it's very easy to notice that the order IDs must be unique. And for that reason, we are going to have a look at the orders table first. Here you can see that we have this order number as a primary key. Primary key means that we are, with this, we are identifying our orders uniquely. And we have also order details table. And in here, we have quantity ordered. So we need to sum up these quantity ordered values together where our order number is the same. Okay, so if we have, for example, order number 1 and quantity order 3 and another row with order number 1 and quantity 4, for example, then as a result, we need to have just one row with order number equal to 1 and quantity ordered equal to 7. Since we have 3 and 4, we're summing the values up together. But how to obtain this if those are in different tables? For those reasons, guys, there exist many ways to do it. There are some join operations, but we are going to use Cartesian product, and actually for if I'm not mistaken, most of these join operations under the hood, it's calling concatenation and doing some filtering on it. So let's just stick with Cartesian product. So we are starting from here. So we're choosing orders and order details table. And since we have two tables, let's rename it to make it easier to work with them. So O and OD. Now, guys, we need to order number. We need to take order number, and we also need to take the total sum of products. So there is this function that we can use for it, and we can here specify the column that we want to sum the values together, which is the quantity order, and it comes from the OD, order details table, okay? But do not forget this very important thing. Whenever we are doing a Cartesian product, it takes two tables and matches each and every row together. So we're getting all of the possible combinations. But this is not what we want, and we want to have a matching condition to make these same order numbers equal and have just one row of equivalent values, okay? And generally, we find this corresponding column. In this case, it's the order number, and make it work that way. So where order O.order number equals OD.order number. So this is our matching condition. And this here we have a very important thing, this group by function, and why we need it. Because as I explained in the example, we're going to have, for example, order ID 1 and quantity 3, order ID 2 and quantity 7, for example. Oh, sorry, order ID 1 again. So the IDs are going to be the same, but the values are going to be different for the quantity. So we need to have just one single order ID, and for the quantity, we want to sum it up. So we want to group by these IDs, okay? So the name also reminds the logic. For that reason, we're just specifying this order number column and writing group by. So now we can use this sum function on this quantity ordered. And let's see the result of execution, which is the following. So we have this unique order numbers, order IDs, and we have the quantities summed up together, okay? All right, let's go to the fourth question. Get those order IDs and their product counts that have more than 15 different products. All right, notice that here we do not have sum of product quantity, but we have product counts, okay? And we need to choose the ones which have 15 different products. So this makes us think that we need to first get the counts and then filter the ones where this count will be greater than 15. So let's see. Again, we are going to work with these orders and order details tables. And guys, we need to take the count of the products. Now let's see. Here we have this order numbers, which is going to be, again, this magic condition for this Cartesian product. And we have the product code. This product code, guys, is the primary key inside product table. But I want to show you that. So we have product code, and we have this unique, we can say like IDs, and we, of course, cannot sum them up in some way together. We just need the count, okay, just as the problem states. But to get that, again, we need to do the Cartesian product, okay? And we, again, need to use this matching condition And now we again take the order number. So at this point, everything is the same. The difference here is that we're checking the count of the product code. So we are counting the values. We're counting the number of repetitions and not summing the values, okay? It's also logical to see that we cannot count because we have string values and this cannot be summed up together. So we need to take count to get the number of rows, okay? Again, we are doing group by to group by those IDs. And here we have a very important thing again. So remember, we used where to add some conditions, but we can use it only before the group by. But after the group by, we have to use keyword which is called having. But yeah, so we're using it, but in the same way as we would with where. So we're just writing our condition, product count should be greater than 15. And notice that this is not an existing column. We just renamed it when doing this count operation. We just renamed it, okay? So that's the result of executing this, which is the following. So again, having this unique order numbers, and we just counted the number of such product rows, and we just took the ones which have value greater than 16. So this means that we are going to have 16 different products. Okay. All right. Let's go to the fifth question. Now we need to determine if there are any products that have not been ordered yet, don't have any order details, by using the set comparison. Okay, this is something very interesting. So let's look at the tables. We have the product table and we have this order details, okay? Order details are uniquely identified by the order number first and the product code second. So we need this composite primary key idea to uniquely identify our single order detail. Now, in the product table, we have all of the product with their product codes. And the question is to get the products that haven't been ordered yet, okay? And this means that we need to take only the product codes that exist in the product table, but does not exist in the order details table. How to do this in a beautiful way? So, just as usual, we're going to start by selecting the product code from table products. And this product code, notice that it's the primary key in both places. We're selecting that. And now we need to give this condition where product code exists in products, but does not exist in the order details. For that reason, we're just writing where product code, not in, and this gives us an ability to write a subquery inside. And we are gonna select product codes, these ones, which are already in order details. So we're gonna acquire these product IDs. Now, since we're writing not in, this compiler will just go and see whether this product code exists in this table. If yes, it will not be added to our results. If no, it will be there for sure. So it will just compare it one by one. All right, when executing this, we are going to get this single result. Means that this has not been ordered yet. If you want, actually, I can prove it to you by writing a query for you. So we are just gonna select product code from order details, where product code equals, let's just copy the value inside. So we need to see whether we have this. All right. Yes, okay, let's close it. As you see, we don't have anything, but we can select all actually, just for you to see. So we have nothing no rows in order details with this product code. Okay, now we're left with our sixth question, which asks to find immediately contact sales representative employees in Paris, write a query that returns their phone number as well as their complete name in last name, first name format. Okay. Now, guys, we need to we see that we have many conditions at the first glance. So this employee needs to be in Paris. She or he needs to be a sales representative, and we need to also modify a bit their first name and last name to have their full name. So let's see. In our employee table, we have this last name, first name, so it's yet fine. But we also need the location of this employee. We can get it by combining it with the office table because we have we know the office code of this employee, which is a foreign key. Notice that, and the primary key and office table. So we can combine them on this office code condition and just take the city. Also, as the problem asks, we need to take the employee phone number, but unfortunately, we do not have anything related to employee phone number, but rather we have this office phone number, so let's take it. All right, we are going to use Cartesian product, as you guessed. So from employees E, offices O, we are taking the phone number from the office table, and from the employee table, we're going to get first name and last name. But I think we need to do this vice versa. So the last name should come first. I just noticed it. Okay, last name, first name. And we're concatenating this just as we did in this second problem right here, and the white space to have them separated. And we are renaming this with S keyword and renaming it to full name to make it beautiful. And now, as you guessed, we are doing this Cartesian product. So we need this matching condition to keep the correct rows together. So we are doing this on the office code because it's a primary key in the office table and a foreign key in the employees. And we are also choosing the ones which city is put to Paris. And from employees table, we are conditioning this job title to be equal to sales rep. So let's just execute this. So yes, we're gonna get this people and the phone number. So I think it's logical that the phone numbers are the same. There is nothing wrong with it because all of these people are in Paris. And I assume we have just one office in Paris. That's why the phone number is the same. Let's just check. Yes, here is that row. And you can see that it's just one office in Paris. That's why phone number is the same as we have guessed. All right. I think this is it for the first homework. I hope you enjoyed this material and see you soon. Bye-bye.